Okay, so we've seen this before where there's a lot going on in one problem. So we just kind of need to break this down, just take it one angle at a time. So I see angles, remember we always ask ourselves, is the angle in, on, or out of the circle, because they have different rules depending on where the angle is located, the vertex of the angle. So like looking at this picture, I really only see one angle that is labeled that is in a central angle. If you notice, angle 10 is a central angle. I see several inscribed angles, angle 5, angle 7, angle 11, those are inscribed. Angle 9 is in, but not at the center. Angle 6, angle 8, angle 4, those are all on the circle, but they're not inscribed angles because they're made with a tangent and chord. Then angles 1, 2, and 3 are obviously outside of the circle. So we just got to remember our different rules. All right, so let's just start with looking at what's going on here. It says that AB, arc AB, is congruent to arc BC. And then it also says that AC is 100. So I'm going to go ahead and write 100 up here for arc AC. And then if the other two remaining arcs, A to B and then C to B, are congruent, well, I know that I have 360 minus the 100 for 260. Then if I divide that, if I split that evenly between the congruent arcs, each one of these arcs would be 130. So this guy's 130. This whole thing over here is 130. Now, I also notice that I have a semicircle because AD is a diameter. So if AD is a diameter, I can find arc BD. Because AD being a diameter, this whole thing's 180. Well, if I know this part over here from A to B is 130, then I know that B to D must be 50. All right, and then that'll also help me find arc CD. So arc CD, if arc CB is 130, then arc CD has to be 80. All right, I'm going to go ahead and erase that stuff I drew on there. Sorry to those of you that hate it when I erase. All right. So we have all of our arcs measured. So now it shouldn't be too hard to do the rest. Looking at this, angle 1 goes with arc BD, or sorry, angle 10 goes with arc BD. So I know that angle 10 has to be equal to it. So angle 10 has to be 50 degrees. When I look at, I guess, we could go ahead and do angles 1, 2, and 3. It's not going to be hard to do those, and those are the first ones that I have listed. So let's take a look at angle 1. Angle 1 is an exterior angle. So I know that it's its outside arc, so it's this arc right here that I'm tracing, this whole arc, minus the inside arc, and then divided by 2, and that's going to be angle 1. So the outside arc is, it looks like 230 minus the inside arc of 130 is going to get me 100, and then if I divide that by 2, I get 50. So angle 1 would be 50. Then angle 3 is also going to be 50 because if arc AB was congruent to arc CB, which is what was stated, I know it's an isosceles triangle, so those two base angles have to be the same. And then that leaves angle 2 to be 80 degrees. But we could verify that angle 2 is 80 by taking the arc from A all the way over here to C, minusing the arc of 100. So in other words, if I take my 260 minus my 100, I get 160, and if I divide that by 2, I get 80. So angle 2 does definitely work out to be 80. All right, so we found angle 1 is 50, angle 3 is 50, angle 2 is 80. Let's go ahead and go to angle 4. All right, angle 4 is made with a tangent, and angle 4 is this angle right here. It's made with a tangent and a diameter. And we know that when we have a tangent made with tangent connecting with a diameter, it is a right angle. So angle 4 is a 90-degree angle. All right, and then angle 5 is inscribed. So we know it's half of its intercepted arc. And if I extend angle 5 extends here through D and C. So this is the arc that goes with it. That arc is 80, so I know angle 5 has to be half of that, or 40. All right, going to angle 6. Angle 6 is made with this chord and a tangent. The arc that goes with the chord is 100. We know that since it's on the circle, we know angle 6 has to be half of that arc. So angle 6 would be 50. All right, angle 7 is an inscribed arc. And angle 7, if I extend it, it goes with this 130-degree arc right here. So I know it's half of that, so it has to be 65. And then, let's see, we have angle 8 is also made with a chord and a tangent. So angle 8 here has to be half of this intercepted arc, which the whole thing happens to be 130. So half of that is 65. So angle 8 is also 65. All right, angle 9 is inside the triangle. Or sorry, inside the circle, but it's not at the center. So we have to average the two arcs that go with it. I'm going to go ahead and erase a bunch of stuff here, and then we'll be able to find that one. All right, never mind. It's not letting me erase. So, okay, here we go. If we take a look at angle 9 is made with this X. And so it intercepts two arcs. It intercepts this arc up here, and intercepts this arc down here. If you remember, when it's inside the circle, we don't subtract them this time. We average them. So I have 100 and I have 50. If I add those together and divide by 2, I get 150 divided by 2, which is 75. So angle 9 is 75. All right, we already found angle 10 was 50. And then I know angle 11 has to be 25. And you might say, well, how do you know that's 25? I know that because of the exterior angles theorem. This angle 9 right here that's 75 is the exterior angle to the triangle OB, whatever that point would be. I know that the exterior angle is the sum of the two non-adjacent interior angles. So in other words, 10 plus 11 have to equal 9. So if 10 was 50, 9 is 75, 11 has to be 25. All right, I think we found them all. All right, so here would be all of your final answers then. If you want to go ahead and pause the video, you sure can to check these, but hopefully you were able to follow along in the video. All right, we have the second homework problem, and that was the one on the next page here. Problem number 35. All right, so hopefully you were able to figure out that this is a circle, and it is centered at the point -3, 2, and then your cell phone is 5 miles away from you. So in other words, your cell phone is on the circle with a radius of 5 that has a center of -3, 2. And if we go back to the equation for a circle, it's x minus h squared plus y minus k squared equals the radius squared. And that's where h and k are the center of the circle. Well, we already know the center, so I can literally rewrite the equation. And we know that the y and the x stay, but everything else gets replaced. So I can rewrite the equation. I'm going to go ahead and replace the h with the h, which was -3. I'm going to replace the k with the k, which was +2. And then I'm going to replace the r with the r, which was 5. All right, and then I can go ahead and just simplify down this equation. So it would be x minusing a negative is the same as adding. And then -2 squared equals 25. And that's the final answer. That is the equation for the circle where my phone could be. All right, if you have any questions, come on in and see me. Happy to help.